Hello and welcome everyone. Welcome to this channel. Today we will solve this math problem. This is a nice algebra problem and it requires a little bit of understanding. These three values are given in this question. a+b+c is equals to 4, a²+b²+c² is equals to 10 and a³+b³+c³ is equals to 22. Then we need to find a to the power 4 plus b to the power 4 plus c to the power 4 and a to the power 5 plus b to the power 5 plus c to the power 5. Let's define certain notation before we proceed to solve this problem. So I'll call a plus b plus c. This is a polynomial of degree 1 with 3 variables. So I'll call this as p1, polynomial of degree 1, and its value is known 4. Similarly, p2 will be a² plus b² plus c² and its value is also known, it's 10. Likewise, p3 is polynomial in degree 3 and this will be a³ plus b³ plus c³ and the value is given as 22. So these three are given. And in this question we have to find the value of p4, which will be a4 plus b4 plus c to the power 4. Now to solve this problem we will try to find a recursive relation in which the value of the current polynomial will depend upon the values of previous polynomials. In this particular case, 3 previous polynomials or polynomials of 3 previous degrees. For example, the polynomial 4 will depend upon 3, 2 and polynomial of degree 1. Say for example, if we had to find the polynomial of degree 11, p11, that is a to the power 11 plus b to the power 11 plus c to the power 11, then we'll try to find a recursive relation in which p11 will depend upon p10, p9 and p8. So we will need to find the coefficients which will come here, here and here. So here what will come is a plus b plus c into p10. Once you do this multiplication, you will get p11, but you'll also get some extra terms which you will need to subtract. So we'll subtract minus ab plus bc plus ca into p9. This will result in some extra subtraction which you will need to add a final term. And this will give you p11. So this is our recursive relation for finding polynomial of degree 11. So in the similar manner, what will be the value of p4? And the value of p5? Now if you look at these coefficients, finding them is very easy. a plus b plus c we already know, this is p1 which is 4. ab plus bc plus ca we can find and abc also we can find. So once we find these two values, we can calculate using this recursive relation polynomial of any degree. We can find p4, once we find p4 we can find p5, once we know p5 we can find p6 and so on and so forth. We can build value of any polynomial. So before we calculate this value, let us first prove this recursive relation, and we'll prove this for the general term which is Pn. So this is our recursive relation for a general polynomial Pn, that is a to the power n plus b to the power n plus c to the power n, and we'll prove that this RHS is equals to this LHS. So let us first evaluate each term of the RHS. So the first term is this. So we need to multiply this with this. There will be total 9 terms. There are 3 terms here and 3 here. So 3 3 is 9. So we'll write all the 9 terms. This a multiplied with a to the power n minus 1 will become an plus this b multiplied with a to the power n minus 1 will become ba to the power n minus 1 plus b multiplied with b to the power n minus 1 will become b to the power n plus b multiplied with the c, bc to the power n minus 1. Similarly, this c will be multiplied with a to the power n minus 1. We will get this plus this c multiplied with b to the power n minus 1. And finally, this c multiplied with c to the power n minus 1. This will give c to the power n. Now if you look here, we have already found a to the power n plus b to the power n plus c to the power n. Right? This is our polynomial Pn. So let's write it as this only. This is what we needed to evaluate. But we also have other terms here like this. Then this. So let's count. There should be 9 terms. 3, 3, 6, 1, 7, 2, 9. So there are 9 terms. So this is right. Last time I missed one term and then I moved on from there. Then later I realized that I have missed one term. Then I had to repeat this whole thing. And that was heavy work. So this time I am being careful. Let us now evaluate this second term. Again you will get 9 terms. 3 into 3, 9. So AB will be multiplied with all these 3. So AB into a to the power n minus 2. Now this a into a will become a to the power n minus 1. So a to the power n minus 1 into b. So I'll write the final result only. A to the power n minus 1 into b. Plus ab into b to the power n minus 2. This will again become ab to the power n minus 1. N minus 2 plus 1 power here n minus 1. And ab into c to the power n minus 2. Likewise for bc. bc into b to the power n minus 2. This will become b to the power n minus 1 into c. Plus bc into c to the power n minus 2. This will become bc to the power n minus 1. Similarly for the third term, ca into a to the power n minus 2. This will become ca to the power n minus 1 plus ca into b to the power n minus 2. This will be ca b to the power n minus 2 plus ca into c to the power n minus 2. This will be c to the power n minus 1 into a. So this is our second term. We have 9 terms here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's be careful. Now we will evaluate the final term, which is abc into pn minus 3, which is abc into a to the power n minus 3 plus b to the power n minus 3 plus c to the power n minus 3. This is simple. You'll get only 3 terms. So abc into a to the power n minus 3. Now a to the power 1 and a to the power n minus 3. So we'll add this power. So it will become a to the power n minus 2. So let me write the final result only. A to the power n minus 2 into bc plus abc into b. So here it will become a b to the power n minus 2 c plus abc into c to the power n minus 3, which is ab into c to the power n minus 2. So this is the third term. Now let's evaluate the RHS. So RHS is what? This minus this plus this, which is this minus this whole term and plus this. So let's copy paste it here. This is the first term copied here. This is your second term, which we need to subtract. And this is the third term, which we need to add. So this is our RHS, and from this we need to subtract this and add this. So you know the subtraction of algebraic terms. You have to subtract this term, then each term will become what? Minus, 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 minus here. So all the signs of the second set of terms will become what? Minus. So if the values are here and here are same, they will get cancelled. So let's start matching. If a term from here and here matches, then that will get cancelled. For example, a b to the power n minus 1 is here and a b to the power n minus 1 is here. Now this sign will become minus, and then when we'll add these two, it will get cancelled. Similarly, a c to the power n minus 1 will get cancelled with this one, a c to the power n minus 1. Similarly, b a to the power n minus 1 will get cancelled with this one. This is the term I missed last time. b c to the power n minus 1 will get cancelled with this one. c a to the power n minus 1 will get cancelled with this one. And c b to the power n minus 1 will get cancelled with this one. So all the extra term from first set of terms has been cancelled. But there has been some additional subtraction, these three terms. And for that we need to add this. So this will get cancelled with here. Mind you, there is a minus sign before here because we have a minus here. So minus abc to the power n minus 2 will get cancelled with this one. And bca to the power n minus 2 will get cancelled with this one. And finally cab to the power n minus 2 will get cancelled with this one. So all the extra terms have been cancelled. What is remaining is a to the power n plus b to the power n plus c to the power n, which is polynomial of degree 11, and this is what we needed to find. This is equals to LHS. So proved. So this recursive relation which we have defined here is good. And using this recursive relation, we can find all the values which we need to find. So let's find the values now. So first we need to evaluate AB plus BC plus C and ABC. So let's do that first. So let us find the value of the coefficient AB plus BC plus CA. we'll use this formula. a+b+c the whole square is equals to a²+b² + c² plus twice of ab+bc plus ca. We know the value of a+b+c, this is 4. So 4 square is equals to a² + b² + c², its value is given 10 plus twice of this. So this 4 square is nothing but 16. So this implies AB plus BC plus CA is equals to 16 minus 10, which is 6 upon 2, that is 3. So we found this value. The value of AB plus BC plus CA is 3. Now we need ABC. For that we'll use this formula. a³ plus b³ plus c³ minus 3abc is equals to a plus b plus c into a² plus b² plus c² minus ab minus bc minus ca. We already know these values. a³ plus b³ plus c³ is 22. This we need to find. 3abc. a plus b plus c is 4 into a² plus b² plus c² is 10 minus ab plus bc plus ca. This we have found as 3. So 10 minus 3. So we now know the values of these two coefficients. ABC is minus 2, AB plus BC plus CA is 3. So we can find all the values. For example, P4 we need to find, which is a to the power 4 plus b to the power 4 plus c to the power 4. This will be equals to a plus b plus c, which is 4, into P3, which is a³ plus b³ plus c³, which is 22, minus AB plus BC plus CA, which has come as 3, into P2, which is a² plus b² plus c², which is 10, plus ABC, which is minus 2, into P1, which is a plus b plus c, that is 4. So we have a simple algebra. We can calculate this. 88 minus 30 minus 8. 50 will be the answer. So we have calculated this very easily. 50, right? And once we know the value of a to the power 4 plus b to the power 4 plus c to the power 4, we can calculate this value also. So let's calculate the value of P5. Let's calculate the value of P5 here only. Now this much of space is enough to calculate this P5. That is the benefit of solving it this way. P5, which is a to the power 5 plus b to the power 5 plus c to the power 5, is a plus b plus c into P4. A plus b plus c is 4 into P4 we have calculated as 50, minus AB plus BC plus CA into P3. AB plus BC plus CA is 3 into P3 is 22. a³ plus b³ plus c³ is 22, plus ABC, which is minus 2, into P2, which is 10, a² plus b² plus c². So what will get? 200 minus 66 minus 20, which is equals to 200 minus 86, which is 114. So the value of a to the power 5 plus b to the power 5 plus c to the power 5 is 114. So we were easily able to calculate the value of P4, P5, and we can similarly calculate the value of P6, P7, P8, P9. All will take only 2 lines now. So in two lines we can build the entire sequence. So this is it. Thank you for watching. If you like this video, please subscribe and also share with your friends. That would mean a lot. And if you have any suggestions or ideas, please write it in the comments. I'll try to follow that. Thank you and have a good day.